In the Solve It, you use what you know about triangles to find missing lengths. You can also find all the other measures of the triangle if you know the measures of two angles and the length of a side, like angle-angle side or angle-side angle, or two side lengths and the measure of a non-included obtuse angle, side-side angle. The law of sines. For any triangle ABC, let the lengths of the sides opposite angles A, B, and C be lowercase a, b, and c respectively. This means that A, little a, is across from angle big A, and so on. Then the law of sines relates the sine of each angle to the length of the opposite side. And here's the law of sines. If we consider the triangle, the sine of angle A divided by the length of side A equals the sine of angle B divided by the length of side B, and that equals the sine of angle C divided by the length of side C. The law of sines. Problem 1. Using the law of sines in an angle-angle side situation. In triangle ABC, the measure of angle A is 48, the measure of angle B is 93, and AC equals 15. To the nearest tenth, what is the length of segment BC? Well, obviously we should sketch a triangle and label the known information. So as we consider what we would think, draw and label triangle ABC. You're given two angle measures and the length of a non-included side. So this is an angle-angle side situation. What we would write? The diagram and the known information. Next, we would think, use the law of sines to write an equation. In this case, it will be the sine of 93 degrees over the opposite side length of that angle, 15, equals the sine of 48 degrees over the unknown side length we're solving for, BC. And then we solve for BC. BC equals 15 times the sine of 48 degrees divided by the sine of 93 degrees. Finally, use a calculator to find BC in decimal form, and we find that BC is approximately 11.16. So we can state the length of segment BC is about 11.2. Your turn. In triangle ABC, what is AB to the nearest tenth?